Alright, I cannot find my homework. I know it's in here because it's a giant packet, but it's very scattered. We don't have a set of problems. We just have piece by piece.
Okay. Are there any problems that you can verbalize? Or do you need to find that homework first?
They're all graph problems.
They are? Okay. Well, you want to look for it for a minute?
Yeah. Alright, I got it.
Okay.
Why
Why don't you take just one picture and send it, and then send successive emails? Because I know if you put a lot of pictures in there, it'll slow down it getting to me. And if I get one, we can get started on it.
Oh, I think the first one I can verbalize. Alright, so it's f of x equals x plus 2. And then it tells me to vertical stretch by a factor of 5.
Okay. So what are we going to do there?
We have to graph
a vertical. Okay. So you have to graph the result?
I have to graph the result, and then I have to, after I graph the result, I have to stretch it by a factor of 5. And I don't know how to do that. I could do it a day before because they had like an H option, an A option, a B option, and a K option.
All right, well, let's talk about this. First of all, let's graph this. How does that graph?
What?
Think of it as y equals x plus 2. How would you graph y equals? In other words, f of x is just another way of saying y.
So it's a linear line that crosses over negative 2.
Over positive 2. It's x plus 2, correct?
Yes.
Okay. What's the slope of that line?
The slope of it is x, up 1 over 1.
It's actually 1. It's the coefficient of x only, okay? So the slope is 1, so there's that line, okay? Now, to vertically stretch something, you multiply f of x by that 5. Okay? So what is 5 times f of x going to be equal to?
5f times 5x. Oh, it's just 5 of x.
5 times x plus 10. You see why?
You do it to the entire equation.
Yeah, a vertical stretch is where you multiply the entire function by whatever the vertical stretch factor is. And since the function was x plus 2, I have to multiply x plus 2 times 5. And so I'm just distributing it. I'm doing that, and it comes out 5x plus 10. So now, if I want to plot 5x plus 10, I got to go up to the number 10 instead of that's 2, and that's 10. And now what's the slope of the new line?
The slope of the new line is 5.
Something like that. That's what a vertical stretch would look like.
Awesome.
Okay. This knowing that a vertical stretch means 5 times the function is important. There's 6 things you can do. And you can define all of them in terms of what happens to that. So what's a horizontal stretch look like in terms of f of x?
That's actually the next problem.
Okay. Same function?
No, it's a new one. It's f of x equals the absolute value of 2x plus 4.
Okay.
Actually, the 2x is separated from the 4. It's the absolute value. Just that one.
Like that?
Yes.
Okay.
And then horizontal shrink by a factor of 1/2.
Okay. And we're supposed to graph both?
This one we're just supposed to write out the equation.
Okay. How do I do a horizontal shrink in terms of f of x? In other words, I did a vertical stretch by multiplying f of x by some stretch factor.
So would you divide it?
No. It's f of cx. The c goes inside the parentheses.
What's the c?
That's whatever the factor is. In this case, it's half, right? So in this case, c is half.
So
I have to figure out what f of 1/2 x is. Now, let's go back one step, just so you understand this notation, because understanding this notation is very critical. What is f of 3?
F of 3 is what 3 is in the equation.
So what is it equal to? In other words, figure it out. How do I get f of 3? Forget this for a moment.
It's x.
No, I'm going to substitute whatever's in the parentheses for x and figure out what it is. Well,
yeah.
That means it's the absolute value of 2 times 3 plus 4. That's what it means to put something in the parentheses other than x. You with me?
Yes.
So if I said to you, what is f of 3x, then I'm going to put 3x wherever I see x. So there's the absolute value, there's my 2, and here I'm going to write 3x. And then the rest of it. And that would become the absolute value of 6x plus 4. So that's the notation here. Whatever is in the parentheses, we substitute as needed. Well, in this case, the constant, meaning the factor, is in front of the x inside the parentheses. So what would this become?
It would become 2 times 1/2 x, the absolute value of 2 times 1/2 x, absolute value sign, then plus 4.
Now simplify inside the absolute value.
It'd be 1x.
Just x.
Just x.
Yeah, we don't write the 1 if we don't usually write the 1 unless it's being added or subtracted. If it's a multiplier or divider, we don't do it. Okay, what else you got?
I also have 20, which is another horizontal one, but I know how to do that now.
Okay, well, now hold on. There's 2 horizontal things you can do. You can horizontally shrink it and stretch it, or you can horizontally shift it.
All right, well, this one says...
What does a horizontal shift look like in terms of my function? Looks like this.
Oh, this one's a stretch.
A horizontal stretch?
Yeah, this one's a stretch.
Okay. All that means is, I might have gotten the last one backwards. When they said shrink by a factor of 1/2, I assumed that meant c was 1/2. Let's do a stretch and we'll see. I think I'm right, but go ahead. A stretch by a factor of what?
A stretch by a factor of 4. It's 4x equals absolute value of x plus 3, absolute value sign, and then the stretch is 4.
Well, hold on. What was f of x?
Absolute value sign, x plus 3, absolute value sign.
Okay. And then they want to know what a horizontal stretch of 4 is.
Yeah.
Factor of 4. Well, again, the horizontal stretch is where you put the multiplier inside the parentheses, not outside the function. And to stretch it by a factor of 4 means it needs to be 1/4. So I think I do have these backwards. In other words, let me just show you what I mean by that. If I had f of x equal x squared, and I say, what is 2x squared? In other words, if I say, what is f of 2x? This becomes 4x squared, but because that number, hold on a minute, this is a shrink because it's greater than 1. So if c is greater than 1, it's a shrink. Yeah, let's review this here. When we have the c in front of the function like that, if c is greater than 1, it's a stretch. If c is less than 1, what I really mean by that is between 0 and 1, it's a shrink. Okay?
Okay.
When I have the c inside the parentheses, it's the opposite. A number greater than 1 means a shrink. A number between 0 and 1 means a stretch. So I think I gave you bad information. I think the first one, which was, or this one, for us to stretch it by a factor of 4, I got to divide it by 4. The first one, we were shrinking it by how much? 2?
1/2. 1/2.
1/2, which means I wanted to multiply by 2. So this was the first one, this is the second one. And it could just be a terminology thing here. In other words, in point of fact, I know that which is the same as this, will shrink my curve. In other words, my parabola that I get from x squared, like that, when I do f of 2x, it will act as a horizontal shrink by a factor of 2, which is the same as a vertical stretch, notice. So it will become skinnier. So if I want to shrink something horizontally, I need to multiply it by a number greater than 1. So now I'm certain that I had it backwards. This is the answer to the first question, and this is the answer to the second. Now, we still have to plug those into our functions, okay? Let's not go back and visit the first one. I think you know what I'm talking about.
Yeah.
But what is this? What's f of x over 4?
Would that be a stretch because we're not multiplying it by 4?
Well, you said it was a shrink, right? No, you said it was a stretch by a factor of 4, which means we have to divide it by 4.
Yeah.
So we have to figure out what f of x over 4 is. How do I do that again? If f of x is this, what is f of x over 4?
Oh, what's the equation that we're using?
Well, I had x plus 3.
Okay, then we would plug in x divided by 4 plus 3.
Yeah. And that definitely is this, and that is also definitely a stretch because the multiplier is between 0 and 1. When you're going horizontally, it's a stretch. Okay, what else you got?
So analyzing relationships.
Okay.
So we're going to be matching the transformation of f with the correct equation shown and explaining my reasoning. So they give me the equation y equals, well, they give me a bunch of equations, but they all begin with y equals, and then it's f of x of something.
Go ahead.
And I got to figure out what it looks like on my calculator.
Okay.
So y equals 2f and then of x of being parentheses.
Like this? So
Yes.
what are they looking? What is y in terms of? Are we talking vertical something, horizontal something, reflection over the x-axis? What are we talking?
It's all in the positive upper right-hand axis.
Okay. What I mean is that when they give you this, this means a vertical stretch by a factor of 2. Now, I'm still a little unclear as to what they want you to do.
Alright, I'll read the thing. It says, in exercises 23 through 26, match the graph of the transformation of x with the correct equation shown. Explain your reasoning.
Okay. So these are some I'm going to need to look at. Can you take a picture of that and send it to me?
Yes. Oh. I'll fix that.
Yeah, this would have been the tough part of online tutoring 10 years ago, huh?
Yeah.
Wouldn't have been able to do it almost without this capability of having you be able to take pictures of stuff and quickly and efficiently send them. Although in general, most math can be verbalized. It's really rare that it can't be verbalized.
Alright, it just sent.
Okay. It'll take a minute or two for me to get it. Let's make sure it doesn't come through my spam. No, there it is. Oops, where did that go? Right here. All right. Unfortunately, cut off the f of x. Or not. Is this the f of x here?
Yeah, we don't, that's, we only use the bottom stuff that I sent.
Okay. So this is our f of x, and they want to know which graph is this graph vertically stretched by a factor of 2. Which one does it look like? And nothing else done to it. In other words, not only is it only, when I look at A, I see only a vertical stretch, no horizontal shift, no reflection, so it's got to have the vertex in the same place.
I don't understand the question.
Okay, let me draw. If I take this graph and vertically stretch it, what happens to it?
If vertically stretching, you would move the middle point upwards, which would...
That's a vertical shift. Don't get that confused. In other words, a vertical shift is f of x plus some c. A vertical stretch is where you multiply f of x. And notice what happens if that point's 0, right? So if I multiply it by 2, it's still 0. So the vertically stretched looks like this. It's skinnier, has the same vertex, but it's basically horizontally scrunched, right?
Isn't that a vertical shrink?
No, this is a vertical stretch. A vertical shrink gets flatter. Notice that there are 6 things. There's a horizontal, well, I call them the horizontal stretch or shrink, that's one thing. And then there's a horizontal shift, totally different. That's the second thing. The third thing is a vertical stretch or shrink, changes the shape of the curve. The fourth thing is a vertical shift, which merely takes the curve and moves it up or down. If I were to look at this, that would be a vertical shift. It did not change the shape of the curve.
Oh, okay.
Would move it down 2 units or whatever that amount is. But when you do a vertical stretch or shrink, it changes the shape. So when I'm looking at 2 times that, that tells me I'm looking at a vertical stretch. Well, if I look at those pictures, the only one that does that is this one. That's the only one that gets more narrow.
Yeah.
So 24 goes with A. Now, let's not do B. Let's hold off for a moment and do D. What is this? In other words, it's important that you be able to define the transformation from looking at the f of x designation. What is this called?
F of x plus 2.
That's a vertical shift. Because we are taking the function and we are adding some c to it. And it doesn't matter what c is. It's a vertical shift up 2 units.
Okay.
Which of those graphs is the only one that's vertically shifted up 2 units?
25.
Okay. Now let's look at C, which is actually the next easiest thing to figure out. What's that called? Because of the way it's f of x plus c with the x plus c inside the parentheses. That is a horizontal shift. So this is horizontal shift, this is vertical shift, this is vertical stretch, this is horizontal shrink.
Can you go through that again?
I sure will. This is vertical stretch, because the number is greater than 1. This is horizontal shrink, because the number is greater than 1.
The B is?
We haven't found the graph of that yet, but we will in a moment. This, because the shift is an x plus c inside the parentheses, that is horizontal shift. Does not change the shape of the graph, merely shifts it 2 units. And which direction does that go? Shifts it which way? To the left.
Would that be 26?
Yes. Well, no, it looks really like it would be 23. And the only reason I say that is because we still have to assign B to something. And the more I look at this, the more I realize that that is narrower than that is. That's almost a right angle. And if you look here, that's much smaller than a right angle. In other words, this angle here is about the same as this. So notice that the vertical stretch has very, very similar effect as the horizontal shrink.
Yeah.
24 we called a vertical stretch because the vertex didn't change position. Well, in 26, the vertex did move. When I do a horizontal shrink of this thing, I don't just leave the vertex in the same spot. I guess it's a little hard. They haven't put a grid on the bottom. So I can only assume that that vertex is at the same place on the x-axis as that vertex, and that this one is actually closer, and this one does represent B. In other words, yeah, let's get that straight, because I haven't explained that totally well. This is what a vertical stretch would do to that absolute value equation. Okay? What a horizontal shrink would do would change the shape similarly, but it would change the vertex also. It would actually make the entire thing move to the left and tighten up. So it would do that.
They each have a... Cool. It's nice because I labeled each of them so I know what each equation looks like compared to the graph and compared to the equation.
The key to all of this is making sure that you know what these are. In other words, if I said something like, what does that mean?
It means it's going to be a vertical stretch.
What does this mean?
That's a vertical shrink.
Yes. What does this mean?
Is that a horizontal shift?
No, it's vertical. Whenever you're just adding a number at the end, it's vertical shift. No stretching or shrinking, just shifting, meaning you're not going to change the shape of the curve. Okay, and not finally, because there's two things we haven't talked about yet. What does that mean?
That's the horizontal shift.
By how many units and which way?
+2.
Well, 2 units to the right. When you say positive, I assume that you want to say right or left.
Okay.
Okay, I mean, as long as positive is to the right, that's correct. And there are 2 last things. One is negative f of x. The other is f of negative x. This one is a reflection about what? Which axis?
The top one is the y-axis, and the bottom one is the x-axis.
Other way around.
Oh.
The way you can kind of tell is, let's take the function y equal x squared. Okay? Well, what would minus the function be? That would mean minus y would equal minus x squared. And if I graphed minus x squared, that's what it looks like, whereas x squared looks like this. So all I'm taking is every single point that was on x squared, and it's the same distance from the x-axis, it's just below it, because it's got a negative sign in front. So when your negative is in front, you know it's a reflection over the x-axis. If the negative was inside, notice that it would be a reflection over the y-axis, but the result would be this, minus x squared, which is the same as what we started with. And if we reflect that over the y-axis, we don't see any difference. So that's as it should be. So those are the 6 things that you can do to an elementary function. We just covered all 6 of them. And it's really important that you be able to recognize them based on that. Because what you're going to end up doing is they'll give you a translated function like this, and they will say, well, what 2 things are happening here? There's a vertical shift by 2, and there's a vertical stretch by 3. All right. I just noticed that I've gone past our time. Are you okay to go? I mean, I can go longer. I don't have any more.
I think I am because I know how to recognize them now. That was the main thing that I missed today.
Okay.
All right, well, thank you.
You're welcome. Have a good week. Sorry once again for your loss, and I'll talk to you next time.
All right, talk to you next time.
Bye-bye.
Bye-bye.